This video, we're going to talk about how to rationalize the denominator using the conjugate pair. It's another way to say that. These problems are like those from 15.4, number 73, 77, 79, 81, and 83. So let's go ahead and look at this first example, 9 over the square root of 2 plus 1. We're going to be using this idea that a plus b times a minus b is equal to a squared minus b squared, and that's one of the ways we can make sure to get rid of square roots if a or b is a square root or both of them. So the only way that I can get rid of this square root of 2 plus 1 and make it rational is to make a multiplication by the square root of 2 minus 1, top and bottom. Nine times the square root of 2 is 9 square root of 2. 9 times a negative 1 is a negative 9. And the denominator, square root of 2 times square root of 2 is 2. And negative root 2 and positive root 2 make a 0. And 1 times a negative 1 is a negative 1. That gives us 9 root 2 minus 9 over 2 minus 1 is 1. And we divide each term by 1 there. And that's 9 root 2 minus 9 for our final answer. Let's try another one here. The square root of 7 plus 7 over the square root of 6 minus the square root of 5. Now we have square roots in both a and b, but it doesn't matter. It's still the same process here. I also have square roots in the numerator that make this one a little messier, but that also doesn't matter. So we're going to make this the square root of 6 plus the square root of 5. This is the square root of 6 plus the square root of 5. And in my denominator, I end up with 6 minus 5. In my numerator, 6 times 7 is 42. And 7 times 5 is 35. And then we have a 7 root 6. We have a 7 root 5. 42 doesn't break down anymore. It's a 2, a 3, and a 7. There's no perfect squares inside of it. 35 is a 5 and a 7. It doesn't break down anymore. So we're left with root 42 plus root 35 plus 7 root 6 plus 7 root 5, all divided by 1. So this is root 42 plus root 35 plus 7 root 6 plus 7 root 5. I think you can see that that is, even though it's more terms, it's simpler than the original form that I started off with. They had square roots in the numerator and denominator. These are all just in the numerator all by themselves. And that's what we want. We don't want any square roots in the denominator when we're done. All right. Now let's look at one like number 79, the square root of 5 plus 1 over the square root of 2 minus 1. So we're going to rationalize that denominator. Square root of 2 plus 1, square root of 2 plus 1. So my denominator is going to be 2 minus 1. So nice that they're giving me denominators that come out to be 1 all the time here. That doesn't work that way all the time in math. 5 times 2 is 10, plus root 5, plus root 2, plus a 1. None of these square roots in the numerator break down anymore. This is root 10 plus root 5 plus root 2 plus 1 over 1 is root 10 plus root 5 plus root 2 plus 1. Right? Just a couple more here. Now we have 7 over 4 plus the square root of x, and we're going to assume that that x is a positive real number. We're going to multiply by 4 minus root x over 4 minus root x, which is that conjugate pair. 7 times 4 is going to give me 28. 7 times a negative 1 is going to give me a negative 7 times the square root of x. 4 times 4 is going to give me 16. And this is going to be minus x. And that is going to be it. That's rationalized. So there's my final answer for that problem. Now we have our final problem in this section, 4 over root x minus 3. And we'll multiply by root x plus 3 over root x plus 3 is going to give us 4 root x plus 4 times 3 is 12. Root x times root x is x. Negative 3 times positive 3 is negative 9. And there we go. That's it for this video. That's also it right now for 15.4. We'll come back next time and start to talk about 15.5, and we're going to solve some radical equations. So we'll see you for the next video.